Well, me and PRX had a very busy weekend at the BAT Outta Hell in Wollongong. Had a great time throwing axes in all different kinds of ways with great people. And one person we met there was Professor Lezanne Ooi from the Uni of Wollongong. Turns out she actually leads a neuro research group here. And so I thought we'd come by on the Monday afterwards, so we're a bit tired and still on a bit of a high, and talk about her work. First up, and most importantly, Professor, what is your actual name and what's the story behind it?
Thanks, Tristan. So my axe throwing name is Ozone, and the story behind that is so that name has been associated with me for a really long time. So my name is Lezanne Ooi. It's an unusual name, but an anagram of Lezanne Ooi is Alien Ozone, and that was my gamer name since I was a teenager. And so when I started axe throwing, and they said, to pick a name, it was obvious to stick with something that has been with me for a really long time. And I'm also a scientist, so I care about ozone and the ozone layer.
And hence you got ozone, and in the name you have the little 8-bit graphic.
Yes.
That's great.
Yeah.
As a researcher, I obviously involved with some of the leading edge work in Parkinson research globally. So what are some of the key projects that you're working on at the moment?
We are funded by the Michael J. Fox Foundation and Shake It Up Australia Foundation across 3 projects that we're running concurrently at the moment. One of those, the first one that we started, is part of a global program to try and understand the differences in cells from people with Parkinson's disease compared to people that don't have the disease. So the way that we do that is it's called disease modeling. So we try and create cells in the dish that represent the brain. And we do that, so donors would donate a little piece of skin or a blood sample, and we convert those into stem cells and then convert those into the different cell types of the brain, like neurons, astrocytes, microglia, all the cell types that are affected in Parkinson's. And we use those to test different drugs or to try and see what might be different about those cells from people with Parkinson's, so that we can then identify biomarkers. So that was the first project. The second project is about trying to understand environmental risk factors or environmental toxins that might cause Parkinson's disease, because we really need evidence to confirm whether or not some of these compounds or chemicals that have been proposed to have links with Parkinson's are actually causing the disease. And that's obviously an important step for making sure that we can prevent Parkinson's in the future. And then the third project is about trying to find the best way to model Parkinson's disease in a dish. So the experiments that I described is quite a simple model that we can create in a dish and then test different treatments. So the idea behind that is trying to find the best way to do that as a way to accelerate drug discovery for Parkinson's disease.
Of course, yeah, when you're looking at developing and testing brain-related treatments, the lead time for those and the ethics people and obviously the safety requirements are paramount, and they take a long time. So we have to short circuit some of those by proving what's non-viable. That's really useful. Yeah.
Absolutely. And I think the other it would be fantastic to have a treatment that can work on every person with Parkinson's, but it might be that some will work on some people and not on others. So finding a way that we can understand which drugs are going to work on individuals, I think, is also a really big area of development for the next few years as well.
Yeah, certainly. And particularly looking at say clinical trials, we need to know for a stage 3 what the results are going to be, and if it comes out where you use a promising trial or treatment on the cohort where it's less effective, you may invalidate the trial.
Absolutely.
Excellent. That's really important for as you said, to accelerate the process.
Yeah.
With the likes of Michael J. Fox in the last decade or so, really putting their hearts on the line and getting everyone's wallets on as well. How has it changed the research field for you in the last decade or so?
So such an important question because, the reality is that, and as you've already mentioned, research in itself is expensive. Drug development takes a really long time. So the funding for research can be quite tricky unless you have this huge boost in research funding, which recently has come from philanthropic donations. So foundations like the Michael J. Fox Foundation or Shake It Up Australia Foundation have just galvanised the research effort in this particular disease. And the reality is that we wouldn't be doing this research without the funding. So, because we need to pay salaries for researchers and pay for all the consumables to actually do the experiments. So we can't do the research without that type of funding. So it's made a huge difference.
What if you had someone come to you now and go, I've got a blank check for a new project? What would it be?
Oh, that's a really interesting question. Of the projects that we're doing at the moment, I think they all bring something quite different. But ultimately, if you want to make the biggest difference for people living with Parkinson's disease, it is going to be about identifying some kind of treatment that can improve daily life. So a lot of the work that we do in the disease modelling space is really about trying to identify new treatments or new ways to treat. And so, I believe very strongly that is an important approach to be able to develop those treatments in the future.
Just thinking about how the abilities of the lab-based testing. Essentially, that could be great ways. There's a growing, post-COVID, in a lot of way looking at using existing drugs to treat new conditions. And so essentially, there could be a fast-track approach of pre-approved drugs.
Yes.
Who be screened rapidly in the lab for first stage treatment options.
Yeah.
That would be a huge short circuit for potentially alternative therapy, or not alternative, new therapies for Parkinson's.
Yes, absolutely. So, and one of the things that you identified about the drug development process takes a really long time, and the safety testing in people is obviously a massive part of that. So we have a couple of programs of research around trying to repurpose drugs that have been identified for something else, and that is exactly for that reason, that you know that they're safe for use in people because they've been trialed for other purposes. But if they can then be applied for a disease like Parkinson's, then it potentially could get to people quicker.
Yeah, excellent. And the funding and funding is crucial, and that linked with accelerated techniques. Massively cut down on multiple avenues, the cost and time to market and to end users. Yeah.
Yes.
As a researcher, you work in more the molecular biology area, which is also, as a nerd myself, it's great. It's very cool. How do things like, say, give Parkinson's affect you as a researcher? Like actually seeing the actual impact of Parkinson's and how your research may affect someone personally.
I think there's a growing understanding in research generally that, for people that are working on a disease, it's very important to connect on a person-to-person, human-to-human basis with people that are living with those diseases, because, it really gives you an understanding of what you're trying to do and why, but also I think it helps to keep focus on what are the most important questions to address. Sometimes I think, even with the best intentions, researchers can get lost in trying to answer questions that, might be interesting from a biological perspective, but, ultimately we want to stay focused on the biggest and most important questions that matter to the people that are living with these diseases.
Excellent, yeah. And in the end, like as I said, I'm an OT. Science is awesome, but the end goal is about making people's lives better and longer.
Yes.
Yeah. Any closing remarks, Logic?
It's been fantastic to meet you, Tristan, and I'm so impressed at your axe throwing, which is incredible. I think you had a fantastic weekend axe throwing, and I am really interested in the idea that axe throwing can actually help you with your movement and help you with your daily life as well. So it's fantastic to see.
Actually, it was great to meet you on the weekend, and it goes to show the axe community is a very, very wide, diverse, and easy community to play in. I'll just pass. We've got a little helper here. He's got wants to give a bit of a lab tour. This is a little mini Rex with his safety gear on. So going to have a look at the lab too today.
Yeah, we'll take him for a little tour.
Awesome. Thanks very much.
Thank you.